Okay, we all know that cramming isn't the most effective study method. Take a look at Abigail, who scored 100% in her exam, spacing her studying, while Matthias was the 57%, cramming the day before. But why was Abigail's method more effective? Imagine your brain as a beautiful garden and the neurons are the plants growing in it. When you learn or practice something new, it's like giving water and sunlight to specific plants in the garden. Just like plants and the roots grow stronger when you nurture them over time, the synapses of your neurons in your brain become stronger through more frequent stimulation in a process called long-term potentiation. So what happens when you cram? Well, it's like expecting a flower to grow overnight after watering it for just one night. Let's take a look at Abigail's brain, specifically her hippocampus, where her memories and learning is condensed with the help of LTP. Here's a better look at the structure of the hippocampus. We will focus on the CA1 and CA3 region, zooming into the connection represented by the yellow line. Now we can see the synapse, which is where two neurons meet to communicate. Displayed, we have the Schaefer collateral axons of the CA3 neuron and the CA1 pyramidal neuron. An action potential comes down the axon and releases a neurotransmitter glutamate, while there are NMDA and AMPA glutamate receptors on the CA1 neuron dendrite. When glutamate binds to the AMPA receptor, it lets in sodium ions, but the NMDA receptor is blocked by magnesium ions. When there's a high frequency of action potentials in the CA3 axon caused by Abigail repetitively studying for her exam material over a longer period of time, more glutamate is able to bind to the AMPA receptor, which lets in more sodium ions that then electrostatically repels the magnesium ions, blocking the NMDA receptor. Once the NMDA receptor is free, there's an influx of calcium ions leading to the activation of CAMP molecule, which then awakens the enzyme protein kinase A. Through even more repeated stimulation by action potentials, this enzyme travels to the nucleus and activates CREB, a transcription factor that switches on genes for protein synthesis, such as neurotrophins that promotes the formation of new AMPA receptors, thereby making the postsynaptic neurons stronger. So by there being more receptors, the synapse gets more sensitive and stronger, thus more memory can be consolidated and better learned.